Would you like to learn how to create your own ethical hacking tools using the programming language C? Well, then our complete advanced ethical hacking course is for you. Hi, my name is Joe Paris, the best-selling online instructor. Together with my co-teacher Aleska, we're going to teach you how to create and build undetectable malware using C. Who is this course for? This course is for advanced ethical hacking students. But if you're more of a beginner and you're looking to learn the C programming language and maybe some more advanced skills, you can also enroll in this course. We also recommend that you have some programming knowledge. Here is everything that you're going to learn by signing up today. In our course, every video has its own purpose. And at the end of every lesson, you will finish with a working malware function. Now, besides just coding malware, we're also going to show you how to disguise it to look like an image or any other type of program that you would like to make it. You will also learn how to perform social engineering attacks and make the target run our malware program. You are going to learn all of this and much more in our complete ethical hacking advanced course. Now, we always want you to feel comfortable before making a purchase. That's why we've uploaded multiple free preview videos for you to view before you take the class. But if you're ready, we're ready. It's time to take action. This offer won't last forever. Go ahead and click the Buy Now button and we will see you in the course. Thanks again for enrolling.
Hello everybody and welcome to this unique C hacking course. Now, in this course we are going to create our own advanced malware that is going to perform multiple things and that will target all Windows systems. So this is a course for advanced ethical hackers, but you can also enroll if you're interested in C programming or if you're just a beginner and you're interested in more advanced stuff such as coding your own hacking tools. In our course, each lecture will have its own purpose, and at the end of each lecture, we should finish with a working malware function. So we will have a goal that we want to accomplish at the end of each video. Besides of coding malware, I will also show you how to disguise it to look like an image or an MP3 file, or perhaps a PDF file, and any other type of program that you want to make it. We're also going to think of smart ways to perform social engineering attack and make the target run our malware program without them even knowing it. So that is going to be a good one. Now keep in mind, even though this isn't a C programming course, I will type the code myself and explain every function we use as we go. But it is a huge plus if you have previous programming knowledge in any language, because we will code in one and only C language, which is known to be one of the harder programming languages. Now let me explain why you should take this course. Well, if you ever wondered how professional malwares and backdoors are created, well, they are created in C language mostly, and this course will give you an in-depth look on how to do that. We'll cover hiding our malware program from the target. We will also cover a little bit of socket programming in C. We will cover establishing connection at any time with our target machine. And we will also take a look at Windows registry in order to implement persistence to our backdoor, which means our malware will start automatically every time the target machine gets restarted. We will see also an example of adding a keylogger in C that will be able to capture any keystrokes that the target inputs in their keyboard, and we will do many other things as well. We're going to code along in this course, which means I will type the code myself as we go, and I will also explain it. But I also thought of the people who want to have the code already in front of them and follow the course like that, because it makes them focus more on the explanation. So I will have ready to download source code in the last lecture of the course. So feel free to download it and follow the course line by line if that is what you prefer. But you should keep in mind that if you are a beginner in ethical hacking and you haven't taken a course on it, this might not be the first course you should take, because this will be rather advanced course. It is basically a course, as I said, for programmers and for ethical hackers with previous experience. But if you're interested and if you're ready to focus a little harder to understand everything, I'm happy to help you with any questions you might have. So anything that you might wonder about, any function that you do not fully understand, feel free to post it in the Q&A section and I will respond as soon as I see it. As far as the platform goes on which I will be coding, I will use my Kali Linux virtual machine to create our programs. But for you, feel free to use any type of environment you want, but keep in mind that the compilation process of a C program is different on Windows and Linux environment. I will show you how to compile the program on Linux systems, and in case you want to follow on the same platform as I do, you can go to this page right here, download VirtualBox, which will help you set up your virtual machine, and then go to the Kali Linux official page, go to Downloads, and you can download the newest version of Kali Linux machine if you want to have the same environment as I do. But the process of compilation and the process of coding the program will be the same on any other Linux system, and the compilation process might be slightly different on Windows. So without further ado, let's get straight into the video where we are going to show our malware capabilities and see how it performs on a target machine. Welcome back everybody, and let's perform a demonstration of our malware capabilities. I always like to show my students what they should expect at the end of the course. So right now, we're going to perform a test of our malware and see some of its functions that you will have at the end of the course. So right here, I have my Kali Linux 2019.4 hacking machine, and right here I have my fully updated Windows 10 target machine. So if I go to my hacking machine and start my server, which is one of the programs that we're going to code, it will listen for the incoming connections from anywhere. So right now, if I go to my target machine, and let's say the target wants to go to the My Vacation Photos folder, which is located on the desktop, they notice that there are 4 images in the My Vacation Photos folder, but they only recognize first 3. So they have no idea from where the wood lake came from. They run the woodlake.jpg, which will open up an image of a lake. Everything will look normally. Even if they close it, nothing will be shown on the desktop or anywhere else. They will have no idea that just by opening this image, they have started our malware. And right now, if I go back to my Kali Linux machine, we can see we successfully established a connection with Windows 10 target machine. And right now, if we want to, we can run any command that you can run in a Windows command prompt, such as, for example, who am I, to check out the machine that you are running on. You can check out the IP address using the ipconfig command. You can check out all of the directories and all of the files that the target has. If you type dir command, it will give you an output of all of the files in that current working directory. And we can see our program is currently hidden in the temporary directory on target machine. Another thing we can do, we can start our keylogger using a simple command called keylog_start. Press here enter, and just like that, our keylogger has started, and it will capture all of the keystrokes that the target inputs in their keyboard. So let's see how that will work. Let's say the target wants to go to the My Secret Passwords folder, and they want to add a new password, for example, for a Steam account. They go right here, they type Steam, 2 dots, enter for the new line, then tab, and then password 321. Let's say that is the password for their Steam account. But if we go back to our Kali Linux machine and type dir once again in the same directory as our malware, we can see there is a new file called windows.txt. If we want to see the contents of the file, we can type the command, which is type windows.txt. It will output everything that the target has inputted in their keyboard since we started our keylogger. And we can see right here, Steam, 2 dots, new line, then tabbed in, and then the password 321. This will also work for any online account and any login page. So if they go, for example, to an Instagram login page, they type in, let's say, video_test as a username and test1234 as a password. If we go back to our Kali Linux machine and type C command as previously, we can see the Instagram credentials have been added to the file. As we can see, video_test and test1234. So now that we know that we can also steal their data, let's see how we can navigate between the directories. We can use the cd command to, for example, go to the C directory, see the contents of the C directory, go to the users, for example, then to the user's desktop. And we can see all of the contents of their desktop directory. If we want to, we can also start different files. And also what we can do is we can create a persistence on the target machine. How can we do that? Well, simply just by using the persist command, which we will also code. It will create an actual persistence on the target machine, meaning it will add our malware to the registry, which will allow us to automatically start our program every time the target restarts their machine, without them even knowing it. So you can see right here, we get the response from our malware, which says created persistence at this registry. So those are just some of our malware functions, and let's say right now we want to quit our program, we can simply just type the Q command, which will close the connection and which will close our program. So we will see how to code all of this. We will also see some of the social engineering techniques to mask our program to look just like a normal program, as you saw in the woodleg.jpg file. It only opened an image and nothing else, but it also ran our malware in the background. So that's about it for the demonstration, and in the next video I will show you a unique way to make any exe file an image. So hope you enjoyed this demonstration, and I hope I will see you in the next lecture. Bye! Welcome back everybody. And in this tutorial I want to show you how you can convert any exe file to look exactly like an image. So for this tutorial you will need two things. You will need an exe file. Basically it can be any exe file that you want, whether it is an interpreter created from the MSF1OM or just some exe file that is located somewhere in your PC. It doesn't matter, you can use any you want. And you will also need a Windows environment which has WinRAR. Okay? So if you are running Windows and you don't have WinRAR, make sure that you download it first before you attempt this, because we are going to need it while creating the image with our malware. Now if you don't have any Windows machine, you can simply just download VirtualBox and download some Windows environment, and then you will have a Windows machine where you can convert your malwares to images and any other file types, and you will also have an environment where you can test our malware once we create it. Okay? So, assuming that you already have Windows and that you already picked your exe file that you want to convert, let's see what else do we need. Well, you're going to need an image, whether it is an image that is already on your computer or the one that you will download from the internet, it doesn't matter. You will need one, so make sure that you get an image, whether it is JPEG or PNG, it also doesn't matter. And once you picked your image, you want to go to your browser, go to your search bar and type in JPEG to ICO. Now it doesn't matter if your image is PNG, you still want to type this. Once the search results are ready, you want to go to the first link, which is https://iconconvert.com, click on it. It should open up this page where the first step is to upload an image. So you will go and choose file, find your image, which in my case it is right on the desktop, and here it is, Dragon. I will select it, I will click on upload. It will take just a few seconds to upload the image. Once it is ready, we want to scroll all the way down. And right here where it says select the icon format, you want to go down here and check 64x64. It will automatically fill in the other circles, which are custom size and multi-size in one icon. Once you clicked on this, go to convert ICO, and in just a few seconds you will see this download your icons, click on it, and it will ask you where you want to save it. So you want to save it onto your desktop, click here save, and it will download it straight away. Okay? So once that is ready, you will have these three files on your desktop. Once again, the exe, the image, and the icon for that image. So once you do that, you want to separate the image and you want to separate the exe. Then you want to select both of them, right click on them, and go to add to archive. For this you will need WinRAR, so that's why I told you to download it. So right here, once you go to add to archive, it will open up this small window where it will prompt you with some different options. The first thing you want to change is you want to go right here and type the name that you want your image to be. In my case, I want my image to be called image.jpg. But since we all know in order for our malware to run, we need to have the exe extension, we want to go right here and click Create SFX Archive. Click on that and you will see it will automatically add the .exe extension right here. Once that is done, you will have image.jpg.exe in the archive name. Then you want to go to the advanced, and right here under the advanced you want to go to SFX options. And right now we need to go tab by tab and set up different options. So in the general tab, we don't need to set up anything, proceed to the Setup tab, where it will ask us which programs we want to run after extraction. The first program that we want to run will be our image, which you need to make sure that you specify the correct name. In my case, it is dragon.jpg, and I need to also keep in mind that I'm specifying all lowercase letters because that is the name of my image. So that is the first file we will run after extraction. Let's type it in, dragon.jpg, press here enter, and right below the dragon.jpg, you want to specify the name of your exe file. In my case, that is backdoor.exe, all lowercase letters, so backdoor.exe. Once that is ready, we can proceed to the Modes tab, and in the Modes tab, you want to check right here, Unpack to temporary folder, and go all the way down and click on Hide All. After you click that, you want to go to the Advanced. In the Advanced, we don't want to change anything. In the module, there is nothing to change. License as well. And right now, once you go to the text and icon, you want to go all the way down and click on the Load SFX icon from the file. Click on Browse and pick your icon that you created using the icon converter that we've just used 2 seconds ago. Pick your icon. Once you do that, you want to go to the Update, and in the Update tab, you want to go to the Extract and Update files, and in the Overwrite mode, you want to go to the Overwrite all files. Once you do that, click on OK. Click once again on OK. And in just a few seconds, we should have our file ready. As we can see, here is our malware that will open up an image once executed. You can see it does have the image.jpg extension, but that is only because in this Windows system, the extension is hidden. So for example, if the extension is enabled, which is not the case in most of the Windows systems, then this file would be named image.jpg.exe, because if we go to the properties of this file, we will indeed notice that this file is the type of exe, even though its name is image.jpg. So let's see what happens once we open this file. I will double click, and in just a few seconds, we can see an image is being opened, and it is the exact same image, which is this dragon image on my desktop. Nothing else is being shown, but I do assure you that our malware is being ran in the background right now. So that would be the tutorial. At the end of the course, once we code the entire malware and all the programs that we need, I'm going to show you how you can perform this same task in order to make your malware look like any type of file you want. Whether it is a PDF file or an MP3, or simply just a browser that is right here in the taskbar, we can also do that if we want to. So we're going to see that at the end of the course. I hope you enjoyed this small tutorial, and I will see you in the coding lectures. Welcome everybody to the first lecture of creating our malware, and in this video we're going to see what options do we want our malware to have. We're going to make a list that we're going to follow throughout this section, and we're also going to include all the necessary libraries that we're going to need for our program. Now keep in mind that in this video I'm only going to explain as much as I can about the C programming, so this is not going to be a C programming course. This is just going to be us coding an actual malware and me explaining all the functions that we're going to use throughout our code. Okay, so first of all, let's create a list. So what we're going to do is we're going to navigate to the desktop directory in our machine. Now, if you're using Windows directory, don't worry. You can code this program in Windows if you like. You can code it anywhere you actually like. But I prefer to code it in Linux environment, so I'm using my Kali Linux machine to perform this. The compilation method for Windows and Linux will be different, but I'm going to show you how you can compile the C program in Linux and make it run in Windows. So our goal is to get an exe file that is going to be an executable in Windows. Okay? So first of all, we're going to navigate to the desktop directory, and right now we're going to create a file which is going to be called malware plan.txt. So right now, what we want our actual program to have is we want to actually make it, the first step, we want to create connection with our server. That is going to be the first step, and we're going to do that inside a main function. So we will have a main function which is going to actually perform the connection to our server. The second thing that we're going to create is we're going to create a shell function which is going to actually listen for the incoming commands from our server and iterate over certain options. So wait for incoming command and iterate over certain options. The next thing that we want to create is we want to create our program to be able to actually run on boot time. So we want our program to automatically start every time the target restarts their machine. So automatically start program when machine is rebooted. Okay? And the fourth thing is going to be that our program is going to be able to actually start any other exe program that we specify in the command. So start/spawn other programs. The fifth thing, we want to be able to navigate through different directories. So we're going to type right here, navigating through different directories. And the sixth thing is going to be implementing keylogger to our backdoor. Now keep in mind that we might not actually perform all of these tasks in this order, but we're going to accomplish all of them throughout this course. And we might actually add anything else that we come up with throughout our coding session. So let's save this program so we have it somewhere, or this file in our case. And right now let's start off with coding the backdoor. So we're going to call it nano backdoor.c. We're going to have it saved on our desktop, and in this video, as I said, we're only going to import the desired libraries that we need. So right here we're going to type include and then open tag stdio.h, and this is standard input. So the next library that we're going to include is stdlib.h, and libraries in C programming have the .h extension, so you're mostly going to import the .h actual files in C programming. Now keep in mind, we are also performing C programming and not C++. So the next library that we're going to need is we're going to include the unistd.h. Let's go with the next one. We're going to need the winsock2.h for the socket programming, which we need in order to establish a connection with our server. The fifth library is going to be windows.h, because we are creating a program for Windows and we're going to need certain functions from this actual library. We also are going to need winuser.h, and we're going to need wininet.h. Okay? These are all Windows actual libraries, and we have one more which is going to be windowsx.h, and the others are just some libraries that we're going to need for certain functions, such as for example string.h. We're going to need that library for manipulation with strings in our program. We're going to need two more, which are going to be sys/stat.h, and one more which is going to be sys/types.h. Now, since we don't really want to explain all of these actual functions, what they perform, you can simply just go, for those of you that are not familiar that much with C programming, you can simply just copy some of these actual names and go to the Google Chrome and type the name of the library that you don't know what functions it has. So for example, let's say you don't know what winuser library is, and you type in winuser.h, and you can simply just click on the first link right here, and you can read everything you want about this library. As we can see, winuser.h contains the following programming interfaces, and you can see all the different functions that this actual library contains, and we're going to use some of them throughout our program. So this is the best way that you can learn anything that you don't understand in the program. You can simply just Google it, Google a certain function, a certain library, a certain variable type, and read everything about it, and you will understand everything a whole lot better. Okay? So that would be about it for this actual tutorial. We just started off with these certain libraries, and in the next video we're going to start off by defining a function that we are going to need, and also by starting up our main function. Okay, so we're going to start our main function in the next video. Hope you enjoyed this short tutorial, and I hope I will see you in the next lecture. Bye! Hello everybody and welcome back. So in the previous video, we included all of these libraries that we're going to need certain functions from in our program, and right now we are ready to start our Windows main function. So as we said previously, our main function is going to accept, or in our case, in the backdoor case, it is going to connect to our server that we are going to run on our Kali Linux machine. So we need to create the connect function in our Windows main function, and then we can perform all the other tasks. So right now, let us start off with defining our function. So first of all, in C, the function is defined with the simple name and then the two brackets. So our function name is going to be win and then main. Okay, so right now I'm going to zoom this in so you can see even a little bit better. We are going to name our function, as I said, Windows main, and we also need to define what type of function is our main function. In this case, we're going to make our function to return an integer, and it is going to also be an API entry function. Okay, so the reason why we are specifying these options for our Windows main function is because since we are coding a Windows program, every Windows program includes an entry point function that is named something like Windows main. It also needs to create an API entry so we can have access to different functions that we're going to use through our program. Now this function also takes a couple of parameters that we need to define between these two brackets, and those parameters are h instance and then smaller h and then capital I instance, comma, h instance, again capital letters, and then h prev, comma, lpstr, and then lpcmd line, and then the last parameter is going to be integer value, and then ncmd show. Now basically h instance represents or is a handle to an instance or a handle to a module. Now the operating system uses this value to identify the executable when it is loaded in memory. And also the instance handle is needed for some Windows functions. Now the hprev right here that we typed as a second parameter, it really has no real meaning. It was used in 16-bit Windows, but now it is always 0. The CMD line contains the command line arguments such as a Unicode string. And the last parameter that we specified right here, which is the ncmd show, that is simply just a flag that says whether the main application window will be minimized, maximized, or shown normally. And that is basically the first thing that we need to do in our function. But before we start coding the actual function code, we need to open up these curly brackets right here, and everything that is inside those curly brackets will belong to our main function. Okay, so since we're coding an actual program that is going to belong to this function, we're going to tab it once so we know that it belongs to Windows main function, and so it looks better. The first thing that we want to do is we actually want to minimize our program, or in our case we want to make it invisible as it runs. So we're going to use this ncmd show variable to actually minimize our program and to also make the console not appear during the running of our program, which is essential once you're creating a virus, a backdoor, a malware for ethical hacking. You don't want your actual target to notice that you ran something on their PC. You'd want them to actually execute your program and nothing to be shown, so they just simply think the program doesn't work. That is the goal. So how we're going to accomplish that? Well, simply we're going to create a stealth handle. So in order to do that, we need to specify it like this, hwnd, and then we're going to call it stealth. And right here we are creating a handle to a window. With the help of this, we're going to make our window not visible to the target. After it, we need to call the allocate console function, and we call it like this. We simply specify the name, then we open normal brackets, and at the end we need to specify dot and comma to mark the end of the line. Now this will allocate a new console to the calling process, and this function takes no parameters. That's why it simply just has open and close brackets. now that we defined our stealth variable right here, we're going to call a function to it, and that function is going to be find window A. This function takes two parameters. The first one is console window class, and the second one is going to be null. Now on our stealth, we will perform this function. It is an actual function from the winUser.h header, I believe, and this function retrieves a handle to the top level window. It takes two arguments. First one is this class name, and the second one is the window name. And the actual window name we defined to be null. Now don't forget to add dot and comma at the end to specify the end of the line. And right here we're going to call a show window function. And the reason why we're calling this is because in this line we will specify whether we want to show a window to our program or not. Now, as I mentioned previously, since this is a malware, we don't really want our program to open up anything. We want it to work in background. Therefore, we are going to specify two arguments for this function. The first one is handle to the window. In our case, that is stealth. So simply just specify as a first argument stealth, and then comma, which is going to separate the second argument, which is going to be the actual ncmd show, which is this variable right here. And ncmd show parameter from our function is an integer, as we can see right here, and we will set it to be 0. Now the reason why we're setting it to be 0 is because in this function 0 means hiding the window and activating another window, and that is exactly what we want to perform right here. So with this actual line we finished off with the part of our program where we actually hide the console. Okay? And right now we are ready to create a socket object and to make our backdoor connect to our server. So we're going to perform that in the next video. This is just a small step that we performed right here, but crucial step since we don't want our target to notice anything when running this program. And in the next video, as I said, we're going to connect back to our server. So I hope you enjoyed this, and I will see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial. And right now let us start off with the creation of socket object that we're going to use to perform the connection to our server. So let's start right away, and the first thing that we're going to need to do, we're going to need to define a certain variable that is going to be a part of a structure called sock address underscore in. Okay, so let's do that right here. We're going to call a struct, which is something similar as a class in any other programming language, just in C there are no classes. Right now we're going to call struct and then sock address underscore in, which is the actual name of the structure, and then the server address, which we can define just simply as serve addr, and then the dot and comma, and right here we defined the actual server address. Later on we're going to need to actually define different parameters to this variable right here, but for now on we're simply just going to leave it right there. And here the second variable that we're going to need is going to be an unsigned short, and that variable is going to be the server port. So the reason why we are defining these two variables is because we're going to need an IP address and the port to which we're going to connect to from our backdoor. Okay? And the next variable, since we mentioned the IP address, is going to be a char variable, and that is going to point with this star to a server IP. And for those of you that are not familiar with C programming, this star right here is simply just a pointer that will point to the memory address of this variable right here. And the last actual variable that we need is going to be the WSA data, and that type of variable we're going to call WSA data. So we're going to call it the same, just this is capital letters and this is not, okay? And simply the WSA data is a structure that contains information about Windows sockets. So this is something that we must have in order to establish a socket connection to a Windows machine, okay? Now that we have all the variables defined, let us simply just type it right here, server IP equals, and right here we're going to type the IP address of the machine that is going to listen for the incoming connection from our backdoor. So this is in my case going to be the IP address of my Kali Linux machine, And how I can check that is I can simply let me just save this, and you save this program just by specifying Control O and then Enter and then Control X to exit. And for those of you that are wondering, I'm using the Nano editor to write my program. Now you can use LeafPad, you can use Vim, you can use anything you want, it doesn't really matter. What matters is that we specify the correct IP address to our Kali Linux machine or to our machine from which we're hacking. And in my case, that is 192.168.1.8, so I will simply just copy this, I will clear the screen, and I will go back to my backdoor. And in between the double quotes in my server IP, I will simply just specify the IP address, okay? And also, since we are specifying the IP address, let us specify the port that we want to connect to right after it, so server port is going to be equal, and right here you can simply just specify any port you want, just make sure that it is a free port and not used by any other application or a program. So I will just simply type here 50,005. You can choose any port you want, if it is an existing port, of course. And since we defined these two, let me just go all the way down. Now that we have defined these two, we're going to use a WSA startup function. And we're also going to use it in an if statement. So I will code it right here and then I will explain. Let's start off with if and then WSA startup. We're going to open another two brackets right here since this is a function, and the first parameter is going to be a make word out of 2, 0, and then after it specify comma, and then this sign right here, as we can see, this sign, and then the actual name of the variable that we defined right here. So WSA data. Now, if this is not equal to 0, then what we're going to do, and we're going to exit the program right here. Okay, so most of you are probably now confused if you haven't encountered this before. So we can simply just check out what WSA startup does by searching it on Google. And I also showed you that that is the best way that you can actually find something out about a certain function or variable in case you don't understand it the best. So let's wait for Google Chrome to open up, and then we're going to search the WSA startup. And then it might be a little bit more clear to you what this function does. Okay? So what this actual if statement does, it is simply checks whether the result of this function is equal to 0 or not. So if it is equal to 0, then it will proceed to the rest of the code. If it is not equal to 0, then it will exit out of the program. And this exclamation mark and equal simply means not equal to. So the result of this function, in case it is not equal to 0, will exit the program. Okay? So let's go right here and type WSA startup. And here we can see another example of our function right here. As we can see right here, it does take two parameters indeed. The first one is the make word, and the second one is the WSA data that we created right here. So let's go right here. WSA startup function winsock.h. So we can also see from which library it is in. And we can see right here, the WSA startup function initiates use of winsock DLL by a process. Here are the two arguments that it takes that we defined, and we can see the parameters, version require and WSA data. The return value is an integer, as we can see right here. If successful, the WSA startup function returns 0. That is the reason why we're specifying right here exclamation mark and equal, which means not equal to 0. So the successful execution of this function will return 0. In any other case, it didn't work correctly. That's why we're going to exit the program. Okay? So let's continue with our program right here. Just go all the way right here. And then what we are going to do after it is we're going to define our socket object. And we can do that simply just by calling this sock equals. And since we don't have the sock actual variable specified, what we're going to do is we're going to specify it outside of the main function. Now the reason why we are doing that is because this socket actual variable we're going to need to use in other functions as well. And if you define an actual variable inside a function, it cannot be used by any other functions that are not the function that you have the variable defined in. So right here we're going to, at the beginning of our program, define the integer sock, since that is going to be an integer. And we also might need this server address to be defined outside of the function as well, but we're going to do that later on in case we need it. For now on, this socket will be enough. So the sock returns an integer, and this socket actual function takes few parameters, which are af underscore inet, that is the first parameter, and this af underscore inet represents that we're establishing a connection over IPv4. Okay, so the second parameter is going to be sock underscore stream, and this second parameter defines that we are going to use a TCP connection or a three-way handshake connection to establish the communication between our server and our target. And the last actual parameter is going to be 0 because we are not defining anything else. And here we can close the actual bracket and type dot and comma. Okay. Now the next thing that we are going to need to do is we're going to need to actually define all the different parameters that this server address will take because it is a part of a structured sock address. Okay. So before we do that, we want to first of all clear it out of any bytes, and we can do that simply just by using memset function. And what this memset function does is it simply just clears the variable with zeros. So for example, let's say that between the double quotes are the contents of our server address variable, and they have some random numbers. What the memory set function will do is it will clear them to be all zeros. Okay, so we can use that right here. Memory set. The first parameter is actually going to be the memory location of the variable that we are going to clear, and in our case you specify that with this sign right here and then the name of the variable, which is server addr in my case. Then the next actual parameter is going to be 0, so we want to actually clean it up with zeros, and the third parameter is going to be the size of the variable, and we can get that with the help of a function called sizeOf. So, and in between the brackets we specify the variable name. Okay, then dot and comma at the end, and we can use this function to zero all the content of this variable right here. Okay, and now we can define different parameters that are going to belong to this variable. So the first parameter we're going to access with this, so server addr, and then dot scene underscore family, and that is going to be af underscore inet, which we already explained to be IPv4 connection. The second parameter, which is going to be called scene underscore addr, and then dot s underscore addr, is going to be the actual IP address of our server. And we are going to convert, since this is an actual string, we cannot use a string to connect to it. We need to convert this string to an IP address format. And we can do that simply just by using inet underscore addr function onto our server IP. Okay? And the last parameter that we're going to need is going to be the port. So server addr dot scene underscore port. And here we're going to use also another function that is going to convert this integer to a port format, and we can use htons function on this server port. And as I mentioned previously, let me just add dot and comma. If you're wondering about any of these functions, you can simply just go in your Google Chrome, type the function name, and you can see what that function does, so I don't have to explain everything that we actually code. Okay? And you will also learn much more just by reading the stuff that this function can perform than by simply looking at the code. Okay? So now that we defined it, we're going to cut this tutorial right here, and in the next one we are going to actually connect to our server. Now I know some of this stuff can be hard for someone that doesn't have that much experience in C, so my advice would be to search all of the functions that you don't understand and to also read through the code multiple times. It really does help a lot, and you will understand it a whole lot better if you simply just go through the code multiple times than just one. Okay, so let us save this, Control X to exit, and we're going to continue in the next tutorial. Bye. Hello everybody, and let's continue right away with our program. So I will just nano my backdoor.c, go all the way down, and what we're left to perform in this main function before we can close it and go to the next function is we need to perform the connection. So we can do that using the connect function, and the connect function looks something like this. You simply just specify connect, and the first argument of the connect function is going to be the socket. Now we define the socket to be called like this, so we're simply just going to define it right here. And then for the second argument, open and close bracket, and in those brackets specify structure, or struct in this case, sock addr, and then a pointer or a star sign. And then outside of the function, specify the memory location of server address, and we do that, as we already know, with this sign and then server address, or serve addr. Okay, so this is the second parameter, and the last parameter is going to be the actual size of the server addr. So size of, and then server addr. Okay, but this is not everything that we want to actually code. We want our program, our backdoor or malware, or however you want to call it, we want that to actually connect to the target, or try to connect to the target every 10 seconds. Now, why do we want it like that? Well, imagine you deliver the payload to the target and they run the actual payload before you start your server. They will try to connect back to you before you have even started listening for incoming connections, and therefore they will go through this part of code. It will not work because they will not be able to connect to you because you haven't really started up your server and listening of connections yet. And therefore this program will stop running. And we don't really want that to happen. We want to be able to connect whenever we start up our server, and we can accomplish that by performing this connect function every 10 seconds until it actually connects. And we can do that simply just by running right here a while loop. So a while loop simply means that we're going to run this actual connect function until it is equal to 0. Okay? So we're going to run this as long as it is not equal to 0. And as soon as it is equal to 0, that means that the connection has been established, and we're going to go to the rest of the code. Okay? And if it is not equal to 0, we're going to perform... Let me just retrieve this bracket right here. It went all the way down for some reason. So let's get back to this. If it is not equal to 0, we're going to sleep for 10 seconds, and we can do that by typing sleep function and then the actual amount of seconds that we want our program to sleep for in between the brackets. And this function simply just makes our program not do anything for the specified amount of time. And then right after it, we're going to do something really interesting that I think only can be done in C and assembly language, which is go to instruction and then start. Now you might be asking, what is this start? Well, we haven't really implemented it yet, and we're going to implement it right before the while loop. And we can implement it like this. So start and then 2 dots. And let's actually go through this one more time so you can understand it a little bit better. We have something called start right here. So let's imagine this start line right here as some type of a checkpoint. And then after that checkpoint, we go to the while loop, which tries to connect. If it manages to connect, it will skip these 2 instructions and it will go outside of the while loop and continue with the program execution. But if it doesn't manage to connect, it will go to these 2 instructions. First of all, it will sleep for 10 seconds, and then it will go to this instruction which says go to start. So it will go right back to start, and then it will perform all of these in circles until the actual connect function works and until the target connects to our server. Okay? And once it does that, once the actual target connects to our server, we're going to enter a function called shell. And in the next video, we're going to start by coding this function, which is going to actually receive the commands from our server, execute them, and send back the output or the result. We're going to see how we can implement that in the next tutorial. So for now on, that will be about it. We managed to actually create a while loop that is going to connect every 10 seconds until it manages to connect. And we also define the socket object as well as the server address. So our main function is close to done right here. We created the API entry entrance. We hid our actual console from the target so it doesn't open up anything. We defined all the necessary things that we need, such as IP and port, and then we connected to the target. And right now, as I said, we're ready to execute the commands. So that would be about it for this tutorial. I hope you enjoyed it, and we are going to see how we can continue coding this program in the next lecture. Bye! Welcome back. In this video, we're going to create our shell function. So the goal of this function is for it to be able to execute the commands that our server will send to the target. So we're also going to perform that in while true loop, but before we do that, we need to allocate some of the different variables inside that function. So let's go and navigate to our backdoor.c. I will open it with the nano editor. Here is the thing that we already coded, which is the Windows API entry main function. And now, as you can see down below in the previous video, we called the shell function, but we don't yet have it, so we need to code it right here. We're going to code it at the beginning of the program, right above the API entry Windows main function, and this function is going to be a void. Now, what does this mean? Well, a void function means that it will not really return anything from this function. If you simply just call a function integer, like this one right here, this means that this function will return an integer number, such as, for example, it will return 1 or 0. But once you call the function void shell, that means it will not return anything. We don't really want to return anything, as this is actually the main part of our program. Okay? So we need to call the open big brackets to make the code actually belong to this function. And right now, we're going to allocate 3 different variables inside this function. The first one is going to be the buffer variable. This is going to be a chart type variable, and it is going to contain 1024 bytes of memory. Okay? So what we're going to use this variable for is we're going to use it to receive the actual command from the server. So let's imagine this scenario. We are running our server that, keep in mind, we haven't coded yet, and we send a command to the target that is going to be, for example, delete this file. So that command is going to be stored in this variable, and we're going to code that right here. Okay, so the next variable that we're going to need is going to be the container variable. So we're just going to call it container. And this variable right here is also going to be 1024 bytes large. And I will explain once we get to the actual end of this function what is the use of this variable. And the third actual variable that we need is total underscore response. And this actual variable is going to have 18,384 bytes. So this is going to be a lot larger than the previous two. And you will see why we need it like that. Once we create all of these variables, we're ready to jump into the while true loop, or in our case, while one loop. As we previously explained, while one loop means that it will iterate forever until some certain breakpoint is called, or until some actual task is fulfilled. Okay? So let's open the brackets for our while true loop. And right here, we're going to create the same thing that we created in our Windows main API entry function, which is this right here. So we're going to create a jump point. And you will see why do we need it. So right now, we're going to code it before anything inside our while loop, and it is going to be called jump, because we are literally jumping to this point after some execution. Now the next thing that we're going to do is we're going to take these 3 variables right here that we just created, and we're going to allocate zeros inside all of the memory that they take. So for example, there are some random actual bytes inside this memory, and we want to allocate zeros to all of them. Now we know that in Windows C there is a function called memset, which we actually used previously, And this actual function takes 3 arguments, which is the variable name, the bytes that we want to overwrite, and which size we want to overwrite. But let's not use this function because we're going to use it a lot of times inside this program. Let's create a smaller function that is going to perform the same task. So we're going to create the b0 function. And for those of you wondering, b0 is a function that is exactly the same as memory set or memset function, just it is usable on Linux. But keep in mind that this program will be run in Windows environment, therefore we can't just simply use b0 and expect it to work. We need to define this function. So how can we define it? Well, inside of C, we can use hashtag and then define. After it, we call the name of the function, which is going to be b0. We're going to call it exactly the same like the Linux function. And this b0 function will take 2 parameters instead of 3. The first one will be the actual parameter, or the variable in our case, and the second one will be the size. So for example, we want to b0 this buffer right here. We'll specify buffer as the first argument and 1024 as the second argument. But this is not everything that we need to do. We also need to say how can it do this. And we can simply perform that action using the memory set function, which is already defined inside of this language. And we can do that just in the same line, call the void memory set function, which takes 3 arguments. If you remember, the first one is going to be the actual parameter. And keep in mind that if you call it p right here, you need to call it inside of this function as well p, because this is all one statement and it needs to have the same parameters. Okay? Then after it we perform comma, then 0, because we are actually overwriting the memory of the variable with zeros, and the third parameter inside memory set function is called size. Okay? So let me see if we got all the brackets correct. So 2 open, 2 closed, and we have these 2. Okay, everything is good. The same goes for the size variable right here. You need to call it the same inside of this function as well. And now that we coded this, we have the b0 function in our program. So let's use it right here. We're going to b0 every single variable that we created right here. So all 3 of them. Let's go with the first one, b0, and then buffer, and then 1024. As we can see, that is the size of the variable. Then we can go on to the second one, which is going to be b0 container. And another way you can specify the size of the variable is size of function, which is already in C, and then the variable name, which is container. So this is another way we can do it. Perhaps a better way than this one. So it is a better practice to actually use this way, to b0 the variable. And the third variable is going to be total underscore response, and then size of the total response. Okay? So right now, let's see how we can use all of these variables. Let's think about it. So the first thing that our program needs to do is to receive the command from our server. So how can we do that? Well, we can do that using the receive function. This receive function will take 4 parameters. The first one is going to be the socket that we created, which we called simply just sock. If I'm not mistaken, let us check it out. Yes, we called it sock. So that is the first parameter of this function. It will receive the bytes on this socket object. Where will it store it is the second parameter. So we want to store the response from the server or the actual command inside of this variable, which is the buffer variable. So we simply specify buffer as the second parameter. And the third parameter is going to be the size of the variable where we are storing our response. So that is going to be 1024 bytes. And the fourth parameter is going to be 0, which implies that we are not specifying anything else besides these 3 arguments. Okay? And now, once we receive this, we can enter our if-else statements. So let's leave that for the next video. For now on, we simply started this function. we allocated 3 different variables, we p0'd all of the 3 variables, and we received the command from the server. Now, in the next video, we're going to see how we can execute that. Thank you for watching and take care. Bye. Welcome back. And in this video, we're going to start off with our if-else statements inside our shell function. So the first thing that we need to do is compare this buffer with different commands. For example, let's say the server wants to quit the connection with the target. We can do that by specifying something that is short and to the point, so the actual user of this program can understand it. So how we are going to perform that? We can simply just send the q command from our server to our backdoor, which we are coding right here. And the backdoor should know that this q as a string will indicate that we want to close the connection and close the program. So how we can implement that? Well, we can simply compare if q equals to buffer, and if it does equal to buffer, we simply just close the socket object and exit the program. But how can we compare? We can't really perform this action right here. What we can do is we can use a function that comes already in C language, which is called string compare. So it is called like this, strncmp. And this function takes 3 arguments. The first argument is going to be the string that we are comparing. The second argument will be the variable that we are comparing the string with. And the third argument is going to be how much characters are we comparing. So in this case, we're only comparing 1 character. And now we need to put this in an if statement. So if, and then we will open a bracket, if string compare of this equals to 0, because if it is equal, if q is equal to buffer, then we will return 0, because this is an integer function, it will return an actual integer number. It will return 0 if these do match. So if it is equal to 0, that means that the server wants to quit the connection, and then we can simply just close the program. Well, first of all, close the socket object and then close the program. So first thing, we will call the close socket onto the sock object, which we created in main function. The next thing we need to perform, because this is going to be ran on Windows environment, we're going to perform the WSA cleanup, which we need to perform after we close the connection, and then we can simply just exit the program. And this is it. So this is everything that we need to perform in this case, where the actual server wants to quit the connection. In any other case, we will execute that command. Let me just make this a little bit prettier so we can follow all the brackets one by one. So how can we execute the command? What we need to do is we need to take the command, which is in string, which is just a bunch of characters, and tell the program this is what you should run in your system. So in order to do that, we're going to perform something that we haven't performed previously, which is going to be the creation of file descriptors. So file descriptors are created like this. You type the file keyword in capital, then the star sign, and then the actual name of the file descriptor. This just means that it will point to that specific memory. Once we do that, we're going to perform something similar to opening of a file. In order to just open a file, you can simply just type fopen, but we don't want to open a file, we want to open it as a process. So whatever is stored in this command will be ran as a certain process or as a certain task that the system should execute. And we can use underscore popen to do that. This popen function will take 2 parameters. The first one is going to be the buffer from which it will read the command. And in order for it to actually read the command, we need to specify it as a second parameter. Inside double quotes, we specify R, which stands for read. So simply we're telling the program, read this buffer and execute it. Okay? But it's not just that simple. We also need to actually get a response from the computer. So we want to send that response back to the server. We can do that using a while loop. And keep in mind, all of this should belong to this else statement, so that is why it is tabbed in. So let's continue, while, and we're going to use the fgets function, and fgets function will simply explain just get string from another variable into a different variable. So we're going to use the container right here. Oops, let me just open the brackets. While fgets and then container, and I will just write it right here, and then I will explain it, 1024 bytes, and then fp is not equal to null. Then what we're going to do is we're going to use strcat function, total underscore response, and then container. So let's explain what this does. We have two different variables. First one is the container, and the second one is total response. What we are doing right here is we're checking if the response can fit into 1024 bytes. So let's go like this. Let us explain it a little bit better. In this line, we execute the buffer or the command inside the buffer. And we also store it inside of this fp. Once we store the response inside this fp file descriptor, we need to read from it and store the actual information inside the container. And container is the size of 1024 bytes. That's why we are using while and then fgets. We are getting 1024 bytes from the file descriptor inside the container variable. But let's imagine the response is actually larger than 1024 bytes. What happens then? We cannot store more than 1024 bytes inside the container, but the response might be larger than that. So that's why we're iterating in a while true loop. We're simply just pasting the first 1024 bytes from the file descriptor inside the container, and then we are actually adding that container into the total response with the string cat method. That means, let's say like this. This is the first part of the response. Let's say this is the first 1024 bytes of the response. We add that to the container, and then from the container we add that to the total response using this function right here. And then it goes back to the while loop, and then it transfers the next 1024 bytes to the container. The container will once again be, let's say, BBBB now. And then we transfer those BBBB and concat it to the previous container and store it in total response, which is going to be this. Now, since our total response is much larger than the actual container, it can store all of the information. And this will be our total response in this case. And all we need to do is actually send that total response to the server. And we can do that outside of the while loop, but still inside of the else statement using the send function. So send, the send function will take sock as a first argument, then it will take the total underscore response as a second argument. The third argument will be the size of the total response. And the fourth argument will be 0, indicating that we are not specifying anything besides this. And in C, once you finish working with a file descriptor, you need to close it using the fclose function. And in brackets, you simply specify which file descriptor you're closing. In our case, we called it fp. So right here, we will specify fp and then dot and comma. So that will be about it for this tutorial, and we will continue in the next one. Bye. Hello everybody, and in this video, we're going to actually jump into our different program, which is going to be our server. Now, I know that we haven't really finished our backdoor, but we have finished the main part. Let me just enter the file. We have finished the main part, which is execution of the commands. So right now, theoretically, with this program, we can do something similar to this, which is executing commands similarly to the command prompt. So for example, if we type who am I, it will give us an output. If we type dir, it will give us the actual directory and all the files inside of that directory. We can type cd to get the path. We can read all of the files by typing type, and then, for example, let's say the target has passwords.txt. We can read them using this command if we want to. We can also get all of the saved wireless passwords with different commands, which I will show at the end of this course. But before we continue adding on to different options to this program, such as, for example, keylogger, persistence, which is going to start the program after the reboot automatically, and also, for example, starting the different programs with that, changing directories, which is also something that we need to add, let's see whether this first of all works. And in order to see whether this first of all works, we need to code the server part, which is going to listen for the connection. So that's why we're going to save this, Control O and then enter, and we're going to nano server.c. Okay? First of all, I will import all the needed libraries, which is going to be first include stdio.h, then just follow up with me right here. We need to first of all, okay, the second one is going to be sys/types.h. The third one is going to be for the socket, which is going to be sys/socket.h. .h. Now we have significantly less libraries right here, so we have only like 3 or 4 more. Let's go right here, net/in.h. The fifth one is going to be the usual one, which is the stdlib.h. The sixth one is going to be string.h for the string manipulation. And we have 2 more. The first one is unistd.h. And the last one is going to be arpa/inet.h. Okay, so now that we have all the libraries included that we need for this server, let's continue with our program. Now keep in mind that this server program will only have one function, which is going to be the main function. And it will be significantly smaller than the backdoor program, because this is only right here to create a connection or to listen for the incoming connection and to send the commands and also receive the response. So let's start off. We are going to open the big brackets right here, and everything inside of this program will belong to this function. First of all, we're going to create all the variables we need, which is going to be the socket and the client socket. Now the reason we need client socket is because we are the server, we need our own socket, and once the client initiates the connection to us, we also need to store the client socket. That's why we are creating 2 socket objects right here, or in this case 2 integers right now. The second thing that we're going to need is going to be once again buffer. The same thing that we did in our backdoor.c with buffer, we're going to use it right here as well to transport the command. We also need the response, and the response has to be the same size as the total response from our backdoor.c, which in our case was 18,384, because it can't be a byte larger or smaller, because that would actually cause some problems inside of our program. It has to be the exact same size as the total response from the backdoor. Okay? Now we need to import the structure of the sockets, so struct sock addr_in, and we need that for the server address, which is going to be our own address, and the client address. So we create both of them. Now in our backdoor we only created 1 socket object, which was the target socket object, but in this case we need to create 2 because we are server and we need to accept the target's connection. We're also going to need a few different integers right here, which I will explain once we get to them. So this is the first one, and opt value equals 1. This is the second one, and the last thing we need is the length of the client socket, which we can specify like this, socklen, and then client_length. And you will see for these 3 variables why we need them in just a second, so don't worry. The first thing that we are going to create is going to be the socket. So we perform the same action as we did in our backdoor, which is going to be socket, and then first parameter af_inet, we already explained what that is, and the second parameter sock_stream for the TCP connection. The third parameter is going to be 0, specifying that we don't really want anything else, and now we want to set some of the socket options, and we're going to use this variable for that. Okay, so in order to check whether our setting of socket object worked, we're going to use the if statement. So if set sock opt onto our own socket, which is going to be the server socket, and then we're specifying some parameters right here, sol socket, and then sol_reuse addr. And right now, we're going to specify the opt value and the size of opt value, because that is where we will store the result. So we are going to specify this sign right here, and if you remember, this sign indicates the memory address of a specific variable that will come right after. In our case, that is going to be opt_val, and this last parameter is going to be the size of the opt_val. Okay, now if this is smaller than 0, then it means something is wrong with setting the socket object, and we will exit the program. So we will print first, printf, error setting TCP socket options. And we can specify the new line character right here. Make sure to add dot and comma at the end, and then return 1. Okay, because keep in mind, this is a integer function, so we are returning an integer out of it. But in case it does work, we will continue with the execution of our program. So we need to perform the same things that we performed previously. So first thing we need to do is we need to set up our server address with all its needed parameters, which are the family, the IP address, and the port number of the connection. So we perform that in the backdoor as well. So let's do it right here. Syn_family equals af_inet, then server_address dot syn_addr dot s_addr equals inet_addr of the IP address of our Kali Linux machine, which I believe is 192.168.1.8, or simply this will be the IP address of your hacking machine, or basically the machine from which you are attacking the target. Okay, so let's add dot and comma, and the last parameter is going to be server_address dot syn_port equals htons, which is a function that will convert the port number. I believe we used this port number, but it doesn't really matter which port you use as long as it is free and not taken by some other software. And the next thing that we need to do, which we haven't really performed inside the backdoor, because this is a function that the server must perform, which is binding the server IP and the server port. And we can do that using the bind function. The first parameter is going to be the sock. The second parameter is going to be the structure of sock addr, pointing to the server address, because the server address actually has these information which we need in order to actually bind the connection. Okay, and the last parameter is going to be the size of the server address. Okay, so you will notice this actual function is similar to the connect function inside of the backdoor. And right now we need to listen for the incoming connections, which we use this function for, which is the listen function. It takes two arguments, the socket on which we are listening and the amount of connections we want to accept. So in this case, 5, let's specify like that. The next thing is going to be the client length, which we actually created right here. It is going to take the length of the client address, so we can specify that like this. Client length will be equal size of the client address. Easy as that. And the last thing before we establish the connection is going to be the accepting of the connection request. And we can do that with simply calling the accept function and storing the result inside the client socket. Because the accept function will return the client socket or the target socket in our case, and we want to store it in this variable right here, which we will then use to communicate with the target. Okay, so accept, and then the first parameter is socket, or in our case just sock. The second parameter is once again the structure of the sock address pointing to the memory location of the client underscore address and the size of the actual client address, which we can specify like this. So client length, because this variable right here stores the size of the client address, that's why we can specify it like this. Okay, so this is our first part of the main function. In the second part, which is a lot easier because it is simply just a while true loop iterating over different commands, we're going to do that in the next tutorial. So first of all, try to understand this as much as possible, because I know if you are doing the socket programming, it can be really hard at the beginning, especially in C language. But keep in mind, the more you read it, the more you search on the internet for a function that you don't fully understand, the more you will get to know how this program really works. Okay, so thank you for watching, and I will see you in the next video. Bye! Welcome back everybody, and let's continue with coding of our server. So what I'm going to do is I'm going to first of all nano the server. Oops, I need to go to the desktop environment first and nano the server.c. And right here we have the first part of our main function. Now we accepted the connection, we set up all of the sockets as needed, we also set up the server address and all of its parameters, and now we are ready to enter the while true loop, where we're going to actually send the commands and iterate over different tasks. So let's go with it. It is going to be a part of our main function, so make sure to code it inside of the main function and type right below the client socket accept function, type while 1. Then you need to open the two brackets, and I'm going to do it like this so we can see everything really good. Right here, the first thing that we need to do is we need to code something that we already did in the previous program, which is backdoor.c, and that is the usage of jump statement. So we're going to code it at the beginning of the while true loop so we can jump whenever we want right to this point right here. Okay? Now, after we do that, we need to b0 all of the variables that we created up in our main function. And those variables are buffer, where we are going to store the command that we're going to send to our backdoor. The response is also something that we are going to b0. And basically that will be about it. All the other variables we don't really need to touch. So let's go right here and use b0. And you will notice that right now we don't really need to define b0 in this program, because b0 exists in Linux C programming. That's why we don't really need to define it, as we are going to run the server on our Linux environment, or in this case in a Kali Linux machine. If you code a server to run on Windows environment, you need to define b0 once again. Okay, so let's go right here, b0, and then we're going to type the memory location of the buffer to clean it up, and the size of the buffer, which is 1024 bytes, but we're going to define it like this. Then we need to b0 the response as well, which is going to store the entire response that the backdoor sends back to us. So we want to clear it every time. Let us type it right here, set the size of response. And the next thing is we need to prompt the user of this server to input a command to send to the target. So for example, let's say we create a connection with the target system. We managed to hack a Windows 10 machine. And let's say we want to see all of the files in the desktop directory on the target machine. We would need to input somewhere dir command, and that dir command would be sent to the backdoor, and backdoor would execute that dir command in its terminal, and then it will gather all the response from that, which is going to be the output of the directories on the desktop directory, and then it would send that response as a string back to us, and then we would print it right here on our screen. So that is the task that we need to accomplish. So let's see how we can do that. what we are going to do right now is, first of all, we are going to printf something like this to make it look better, shell, and then hashtag %s, and then this sign right here, and then $sign. This makes it look like a regular shell inside of a Linux. And 2 dots at the end, space, and that is the first argument. The second argument is going to be whatever we want to input instead of this %s, because this %s actually requires a string to be replaced right here, and we want to input there an IP address of the target machine. And we can do that using this function, which is inet_ntoa, and that function takes an argument of the client's, or in this case of the target's, IP address, which we can actually access like this, client_address, and we can see that the argument that stores the IP address is syn_addr. That's why we're going to type it right here, syn_addr. And once we print that, we need to wait for the user of a server to input a command, and we need to store it somewhere. So we're going to store it in our buffer. How can we do that? Well, we can use the fgets function, which will get the string and store it as a first argument, which we want to be a buffer, so it will store it inside a buffer. The second argument will be the size of the buffer, which we can access simply using the size of function. And the third argument is going to be how we want to access this information, or defined simply from where we are getting the command. And we are getting the command from the standard input, so we're going to specify right here std_in. Okay? Now we need to use a little bit of a string manipulation right after we get that. So for example, once you input a string inside the program, let's say this is a string, it will automatically sometimes have the new line character, which is /n. Imagine us actually sending this to the target and it tries to execute this, it would not recognize this command. For example, let's say we hack the target and we want the target to actually execute, for example, pwd, which stands for print working directory. So we input in our server pwd, but it sends pwd/n with a new line character. The target will try to execute this and it will fail because it doesn't recognize this as a command. So we need to remove this, and now we can send this to the target. So let's see how we can do this. We can use the strtok function to actually remove the /n from our string, or pardon me, \n, because \n is a new line character. So we first specify from where we want to remove the desired character, and the second argument is the character that we want to remove, in our case \n. Okay? Once we do that, we're ready to go. So all we're left to do right now is send the command to the target. We will use the write function to do that, and write is same as send, but it is a little bit easier since it takes only 3 arguments, and the first argument is the client socket, because we are sending this to the target. The second argument is what we are sending, and we are currently sending buffer, and the third argument is the size of the buffer. And now we successfully sent the command to the target. So now we need to check for the different options of what the command was. So you remember in our backdoor, we checked whether the buffer was equal to Q, and if it was equal to Q, we would quit the program. We need to do the same thing right here. So we're going to start with an if statement, if string compare of Q with a buffer, and we compare one character equals to 0. In this case, this means that it is equal. What we are going to do is we are simply just going to break from this program and close it. We don't need to perform any WSA cleanup, which we performed in backdoor, because this is a Linux environment and there is no WSA in creation of a socket. So this is a little bit simpler. The next thing we want to do, in case this isn't equal to Q, we want to receive the response from the target. So we are going to type here else statement, which means any other case where it is not equal to Q. What we're going to do, we are going to first of all, receive the response from the target, and we use the receive function to do that. So receive client underscore socket. We want to store the response inside the response variable. We need to specify the size of the response variable. And the fourth argument is going to be the message underscore wait all, which will be all capital, and this flag will tell the program to block the operation until the full request is satisfied. And for those of you that are interested in receive function and all of its flags to see how they work and what they can do, you can visit this website right here, which is the manual page for Linux functions. And you can see right here the receive functions, and all of its flags are down here. So there is quite a few of them. Okay, we used this one. So for anyone who is interested, you can check it right here. Okay, so let's get back to the program. Right after we receive the actual response, we want to print it out. And we can do that simply just by using printf statement. We want to print it as a string, which we can specify with the %s, and then comma, and what we are printing as a string is the contents of our response variable. And that is basically it. With this, we finished our while true loop in our server. And in the next video, we're going to first of all test this program, see if it works correctly, and if it does work correctly, we're going to proceed to adding on different functions, such as, for example, changing directories, creating persistence in registry, and also starting a keylogger, and other things as well. Okay, so thank you for watching this tutorial, and I will see you in the next lecture. Bye! Welcome back, everybody. And in this video, we're going to perform the first test of our malware. Now, I know that we haven't added all the functions that it should have, but right now we added the main one, which is executing the commands and quitting the program. If this works, then we can continue adding on to different functions, such as keylogger, such as starting other programs, such as persistence, on reboot time. But first of all, let's see if this main part works. So I will open up my terminal, and there are going to be a few things that we're going to need right now. And one of them is a program for compilation. Now, the process of compilation is different on Linux environment and on Windows environment. If you're coding these programs in Windows, for example in Visual Studio, feel free to compile them there. And if you're coding in Linux, we're going to need a program called Ming. Now, I don't think it comes pre-installed on any Linux environment, so we'll have to download it. There are certain steps which are very easy. apt-get update and then apt-get install mingw and then -w64, which is the screenshot of this command right here. If that doesn't work, down here you have some of the solutions for different errors. Okay, so it is once again on this website right here. Now, since I already have it, I'm going to continue the compilation. But before we even compile the programs, we must make sure that certain things are set as they should be. And one of those things is the IP address, also the port on which we are connecting. So they have to be the same as this Kali Linux machine, and they have to be the same in both programs. So first of all, I will type ifconfig to check out my IP address, which is 192.168.1.8. And now I'm going to enter both of these programs. Whoops, let me first go to the desktop, nanobackdoor.c, and check out whether the IP address is correct. The IP address is correct. The port is 50,005, so we must make sure that the IP address and the port is exactly the same in our server as well. So let's go right here. We have the same port and we also have the same IP address. So right now we're good to go and we can compile our programs. I'm going to start off with our server. Now keep in mind that we're compiling two different programs for two different platforms. In my case, I will run the server in this Kali Linux environment, which is a Linux operating system, so I will need to compile the server for Linux operating system. And our backdoor or our malware is going to be compiled for Windows. That's why we need to compile it for Windows operating system. Okay, so let's start off with the server. In order to compile the server, after installing the program that we need, you can simply just type gcc, then the name of the file that you're compiling, which in my case is server.c, -o, and then the name of the file that you want the compiled program to be called. In my case, I will simply just call it server, okay? So once I press here enter, we can see there are some errors in this program which we need to fix. The first error, let's see right here, is in this line, and it is letter L that doesn't really need to be here, so we need to remove this. As well, in this line, we are missing a dot and comma. So this actual compiler is really good because it tells you exactly where the errors are, as well as what are the errors. So in this case, we need to remove the L, and here we need to add the dot and comma at the end of the line. So let us do it right away. Let's go right here. Here is the line where we need to add dot and comma. And here is the line where we need to delete L. Once we fix all of that, let's save this, exit, and let's compile the server once again. And we can see right now, we don't get any errors, and our server is compiled, and it is stored right here on the desktop. Okay? So right now that we have the server compiled, we can compile the backdoor. Now, the command for compiling the backdoor is a little bit longer, so we will need to go slowly right here. The beginning of it starts like this, i686-w64-ming w32-gcc. So this is the program name. The compilation is going to be for Windows 32-bit, and the reason why we're compiling our program to be a Windows 32-bit program is because a 32-bit program can be ran on both Windows 32-bit and 64-bit. If our target was, for example, 32-bit machine, and we compiled our program to be a 64-bit program, then it wouldn't really run on that target system. In this case, it will run both times, okay? So we type i686, then -o, then we specify the file name that we want our compiled program to be called. We can call it malware.exe. After it comes the name of the file that you're compiling. In my case, that is backdoor.c. After this, we need to specify a few different libraries in our command that are used for socket Windows programming. And the reason behind that is because we are compiling a Windows program on a Linux environment, and we need to let know our compiler that we are using some of the Windows libraries, such as, for example, -lw soc32 and -lw -inet. Okay, so I will just zoom this in so you can see it even better, and here is the entire command. Once you enter this command, press here enter, and we can see we also got some errors right here. In the first one, we are missing a bracket before connect, as well as after size of. So let's fix that right here. Nano backdoor.c. Let's go all the way down where our connect function is, and right here we need to add brackets. And since we opened the bracket right here, we also need to close it right here. Save this. And let's try to compile it once again. And we can see this worked as well without any error afterwards. Now, since we got both the programs compiled, let us transfer malware to our Windows environment right here. Since this is just a first test, I will not try to make this an image, or I will not try to make this as least detectable as it should be. I will just simply see whether the program works. So I will transfer it over a USB drive and run the command mv malware.exe/media root and then the name of my USB drive. Once I moved it there, I will unplug the USB drive and I will run my server. Once I run my server, I will run the program. Let me just paste it onto the desktop right here. So here is our malware. If I double click on it, you will see nothing really happens. There is nothing opening right here. The target would probably think that this program is not working. But if we go to our Kali Linux machine, we can see our shell prompt right here. And we can execute the commands if we want to. So for example, if I type who am I, it will give us the output of the name of this PC. If I type, for example, ipconfig, it will give me the IP address of my Windows 10 machine. If I type, for example, dir, I can see all the files in the current directory of the desktop of this machine. So our execution of commands works. Let's see whether the Q command works. If we specify Q, we quit the program. So everything works really well. We can execute the commands, we can quit the program. All we're left to do in the future videos is add different functions to our program to make it even more dangerous. And at the end, I will show you some of the techniques on how to hide the program, how to make it an image, an audio file, a PDF, or whatever you want to make it. And also a few steps that you can do in order to make it even less detectable by antiviruses and Windows Defender. So, hope you enjoyed this little presentation of our first test of malware, and we will continue adding on to it in the next tutorial. Bye! Hello everybody, and welcome back. In the previous video, we performed our first test of our malware, and it worked correctly. With some minor issues that we were able to fix, we got our program to work and execute our commands. Right now, we need to add on to its options. So, we have the two files right here, and the first thing that we want to do is to be able to change directories once we hack a target machine. So if you test our program until now, you will notice that even though we can actually execute the commands, there are certain commands that we still can't execute, such as, for example, the cd command. The cd command stands in both Windows and Linux for changing directory. You simply just type cd and then desktop, and it will change the directory into the desktop. And then you can type dir, and you will see all of the files and folders inside of that directory. And these two commands also work in Windows the same way. But if you run this from our program and you type cd desktop, you will see it will not really change the directory to a desired directory. And right now, let's see how we can fix it. Well, it will actually be a little bit harder than it seems. And we're going to start off by opening our backdoor.c and navigating to our void shell function. So what we want to do is we want to add an option for the changing of directory somewhere around here. So we're going to create an else if statement between these two. So go to this bracket, press here enter, and type here else if. And what we want to do, we want to compare the command with cd. So we will use the same function as string compare. Let's type it right here, strncmp, and we want to compare the cd with the buffer and to characters. Okay, so we are comparing this right here. But if we were actually to leave this with cd and two characters being compared, it would still not work. What we need to do is we need to compare first 3 characters, and we need to compare it with cd and then empty space. So simply just type cd and then empty space between your double quotes. You compare it with a buffer and you compare it with number 3. And now I'm going to explain why are we comparing it like this. Well, once you're changing the directory, the entire command will actually contain the cd part and the directory part. So for example, what I'm going to do right now, I'm going to open another terminal and open LeafPad, just so you can understand everything better. As we can see right here, this is what the command looks like. And it doesn't have to be desktop, it can be any other directory, such as, for example, downloads. So if we compare just cd with our buffer, it might actually mistake it with a simple cd command, which in Windows prints current working directory. So let's check out how these commands work in Windows by opening up our command prompt right here. And if I type cd, you will see it will give me a prompt of my current working directory. But if I type cd, for example, and then c, oops, it's cdc and then slash, you will see that it will change the directory to the C drive. So these two commands are not the same. And we don't want to mistake one with another, so that's why we compare first 3 characters. If in our command there is an empty space, that means that after it will come the directory name. If there is not an empty space, that means that the command was a 2-letter command and it was just cd. Okay? So I will leave this LeafPad for now because we're going to need it in just a second. I'm just going to delete this. Let me close this and close this. Go back to our program. And right now, since you know why we're comparing first three characters, let's continue. Else if string compare equals to 0, then what we need to perform is a changing of the directory. And there is an actual function in C which is called chdir, which allows us to specify the directory name between the brackets, and then it will change the directory inside of our program to that specified directory. But how can we actually do this? We cannot specify buffer right here, because buffer would be the entire command which contains cd space as well as the directory name. So once the program tries to change the directory to, for example, cd desktop, it will get confused because it also has this part in it. So we need to somehow actually cut off this first part and then leave the buffer to be only the directory name, so we can specify it inside of these brackets. And I have a function coded that will do exactly that, and we're not going to code it because it will take a lot of time. We're just going to add it to our program, and don't worry, I will also add the function as a code resource inside of the course. So here is the function right here. As you can see, it is quite a large function, and it is called string_cut. And what this function actually allows us to do is exactly what I mentioned previously, which is to cut a certain part of our strings. For example, let's say, and I will write it down here, or let me just add another window right here. So we're going to leave this function on a side, and we're going to code right here. So let's say we have a command cd desktop, and in actual C we have the chdir function that needs desktop in between the brackets in order to actually change the directory successfully. So what we need to do is we need to cut off this first part and make it like this, and then specify the result inside of the function. And this right here allows us to do that. So this string cut function takes three parameters: the string, the slice from, and the slice to. So let's explain it even better. Let's say we have a command that says cd downloads. We can cut off the downloads part using the string_cut function that we coded, and then in between the brackets we specify the entire string, and let's say this string is stored in our buffer like this, and then we specify as a first parameter the string name. The second parameter is the character from which we want to start cutting, and in our case it will be character number 3, and we want to cut until the end. So to make sure that we catch all of the characters, because we cannot really specify 5 right here, because 5 would cut up to here, and we can't really specify 10, because imagine if there is a directory that is more than 10 characters long, then it will still not work. But if we specify 100, then it is most likely that we will catch all the directories, because there is really not a directory that is over 100 characters long. So what the result of this function would be is simply downloads. And then we would pass those downloads, or we would pass it like this, copy this, inside of this function, and then we would have the successful changing of the directory. So let's implement that in our program. First thing that we're going to do, we don't want to save this. First thing that we're going to do is we're going to copy our function and add it to our program. We want to add it right at the beginning, so go all the way up, and above the void function, or above the void shell function, we want to paste our string cut function. And the contents of this function are simply just different string manipulation that allows us to perform the cutting of a string. So let's go all the way down now that we have our function, and let's add it right here. So we want to change the directory to a string cut, so string_cut, open the brackets, As you remember, first parameter is the command, which in our case is stored in buffer. The second parameter is from which character we want to cut, and that will always be number 3, because we are cutting first 3 characters, therefore we are cutting from the third character. And the last parameter is going to be up to which character are we cutting. In our case we will specify 100, just to make sure that we gather all of the characters from each directory. Okay? And this is actually all that we need to do in order to be able to change directory. Let us save this. And with this we are done. So in the next video we're going to see how we can actually create persistence with our shell. And by persistence I mean adding our file to a Windows registry and allowing it to run every time after we restart the computer automatically. So hope you enjoyed this tutorial, and I hope I will see you in the next lecture. Bye! Welcome back everybody. In this video we're going to start off with our function that is going to create persistence to our target. But before we actually code that function, I just want to make sure everyone understands what we are creating. So this will not be a coding lesson, but rather a short lesson where I will lead you through Windows registry and show you where we are going to store our registry key for our program. If you go to your Windows environment and you go to this search bar right here, you can simply just type the command run, click here enter, and it will open up this small window which will ask you to input a name of the program that you want to open. In this case we want to navigate to our registry, so we'll simply just type regedit, which stands for registry edit. Once you type that, click here OK. It will ask you for the administrator password. Since I don't have one, I will simply just click here yes, and it will open up my registry. Now, registry looks like this in case you haven't seen it, and this is basically the heart of Windows. This is how Windows functions, with different registry keys and different registry values. Now, there is a certain part of this registry where if you add a registry value for a specific program, it will let that program run every time you restart the PC without you actually having to click on it or turn it on manually. And that part of the registry is located at this path. So this exact path is exactly where we're going to store our program registry key in order to run it every time automatically at reboot. So I'm already in that location, and you will see once we actually test our program for the second time at the end of this course, you will see we will successfully create a new value right here which will belong to our program. This data right here will be the path to our backdoor. This will be the same type of reg_cz, and here we will have our value named whatever we want. So basically what I want you to get out of this video is that we are creating a registry key that is going to be stored at this location in order to actually enable us to run our program automatically at reboot. So we'll see in the next video how we can implement that to our program. Now that you have the basic idea, let's get straight into it. Okay, so now that we know what registry is and how to access it in Windows, let's see how we can access it in our backdoor program. So let's nano our malware, our backdoor, and go to our shell function, where first of all we need to add option for persistence before actually coding the function where we will do the persistence. The same way we did right here with the CD, we first of all created this option right here and then added a function which will perform that exact option. So let's go with the same idea, and down below the CD command, we're going to add another else if statement, and this time we're comparing the buffer, so string compare, we already know what this function does. We're comparing the buffer with the command which will be persist. So you don't really have to use this command if you don't want, you can specify some other command, but I will simply use persist because it gives us an idea of what we are doing. So persist has 7 letters and we are comparing it with buffer and then 7, standing for 7 characters, and we want to make sure that is equal to 0 in order to perform the function which will be boot run. Okay, So right now, let's go up and let's code the boot run function. So what I'm going to do is I'm going to code it all the way up, right above the string cut function, which we added in the previous video. Here, we're going to add an integer of the boot run. Okay, now this function will not take any type of input, and we'll make this an integer because it will return an integer out of it. Which means it will either return, for example, 0 if everything works correctly, or it will return -1 if we run into some error. So let's see how we can do this. What we need to do is I'm going to open up our registry the same way we did in the previous video. In order to help me actually create this function, I'm going to open it up right here, click here yes, and I'm going to lower it and open it up as we need. Now, the first thing that we're going to do right here is we're going to create two variables. One of the variables will be the error variable, which will give us an output if we run into a problem, and the other one will be the success variable, which will give us an output that we successfully create persistence. So let's go right here and create the first one, which will be the type of char, and then we will call it ERR. It will take only 128 bytes, and it will simply just be a string that says failed, and then the new line character. Okay. The next will be the success variable, which will also be 128 bytes. And this will be a string that says created persistence at, and then we're going to specify the path where we're creating the persistence. So we're going to write it here, hkey underscore current underscore user, which is the same path as we showed in the previous video. This one right here, just without this computer and then backslash. We're adding everything from here. Let us go and add it. So backslash backslash software backslash backslash Microsoft, then another backslash backslash Windows, Windows current version, and then run, and then backslash n for the new line character. Okay, so now that we created these two variables, we're going to need two more, and the next one will be a type of tchar, and the tchar is basically a Windows 32 character string that can be used to describe ANSI, DBCS or Unicode strings. And we're going to call this as zpath, which is going to take the max path value. And basically the max path is maximum path length limitation, and on Windows 10 it is 256 characters. So we're going to use this variable to actually store path and to get the path to our own malware. Okay, and the fourth variable is going to be type of dword, which stands for double word, and we're going to call it pathlen. Pathlen stands for path length, and we're going to make it 0. And dword is basically a short for double word, and it is a data type that is an unsigned 32-bit unit of data, and it can contain an integer value. Okay, as we can see right here, we added 0 to it, so it for sure can contain an integer value. The next thing we want to do in our function is we want to use this pathlen variable that we just created and perform a function on it, which is called get module filename. So this is a function in C, and this function takes 3 arguments. First one will be null, the second one will be the sz path, and the third one will be the max path. And this function will retrieve the fully qualified path for the file that contains the specified module. In our case, we're getting the path to our malware. Once we perform this function, we need to check whether everything works successfully. So we're going to run an if statement. So if pathlen equals to 0, which means we got an error, we're going to send to our socket object. So send sock, we already know this function, the error, And also we need to specify the size of that error, as well as the fourth argument, which will be 0. Okay? And then we will simply just return -1 from this function, from this bootrun function. Okay? So let's go and continue. The next thing we need to create is, since we are adding in registry, we need to create the registry key value in order to actually be able to input our program to this registry. And how we do that in C, we simply create a new variable, which is going to be the hkey variable, and we're going to call it new val. Okay? And this value is basically just a handle to an open registry key. So now that we have this value right here, we can perform the function in an if statement, which is going to be registry or reg open key. So we are opening registry key, and this function takes 3 arguments, which first one is the actual part of registry where we are opening our key. And if we go to our Windows registry right here, we can see there are 5 main parts. Let me just go right here. We can see there are 5 main parts, and the one that we are interested in is the hkey current user. So we are going to specify that right here, hkey underscore current underscore user. The next argument will be the path inside of that registry. So the path will simply just be everything after it, which in our case is this. So let us copy this without the \n. And inside of text, inside of the brackets, we need to specify double quotes and paste the rest of the path. So this is what should be inside of these brackets. And the last argument is going to be the memory location of our new value. So in order to do that, we will simply specify it like this. And this cannot be equal to error underscore success. So once again, what this line basically means is this function will perform as it says. It will open up a specified registry and it will try to add the new value to it. So if this doesn't work, what we're going to do is we're going to once again send the error to our server to notify it that this did not work. Okay, so we're going to send to our socket object the error and then the size of the error, and the last parameter once again 0, and we will return -1. Okay, so oops, let me just go and tab this bracket in so we have organized space. Okay, so right now that we opened up the registry, we need to set the value. In order to set the value, we first of all need to create another variable, which is going to be the word type, which we already know that it is a double word, and it is going to be called path length in bytes. It is going to be equal to the path length variable that we already created right here. And we are going to multiply that with the size of the sz path. And how we are going to write that is inside the brackets, you type this star sign and then the sz path. Okay, so this might be a little bit hard for you, but don't worry, this function bootrun is actually the hardest function that we are going to code, and it is soon to be over. All we are left to do right now is we are left to actually set the value that we opened inside of our registry. And we are going to do that once again inside of an if statement. So if, and then the function name is reg set value x. And this x basically means that it is going to look for an error. And right here, we specified reg set value x. The first argument is going to be the new val, which we opened up right here. And we created right here. The second parameter is going to be the actual name of what we are creating, and by that I mean if you go to the registry and you go right here, under the name tag is going to be our name, and here we can specify anything that we want. For example, we can specify something like text, and inside of this will be double quotes and then hacked. Okay, so we need to specify it like this. The third parameter is going to be 0. The fourth parameter is going to be the reg_cz. And reg_cz basically stands for this type right here that we are creating. In our case, we want to create the same type as this, which is reg_cz. That's why we are typing it right here. The next parameter is going to be a little bit tricky, and we are going to specify it like this: lp byte, and then cz path. So lp byte from the cz path, and then the last parameter, path len in bytes. All of this has to not be equal to error_success. And once again, with this function, we set the data and type of a specified value under a registry key. Okay? And if this doesn't work, what we are going to do is we are going to close the key. First of all, we need to do that. And for us to close the key, we need to use the function reg close key. And which key are we closing? Well, we are closing the only key that we created, which is this new value key. So inside of it, we specify new val, and we send the error to our socket. So sock error, size of error, and then 0. Okay. After it, we return -1, and we are almost done. All we are left to do right now is actually send the success message in case this all worked. And we are doing that at the end of all of these if statements, because in case all of this worked, that means we created the persistent successfully. And right now we can successfully close the key value. So we are doing the same thing that we did right here. Just this will be the case if it doesn't work, and this will be the case if it does work. So reg close key, and the key will be new val. And down here we want to send the success error, so we need to specify socket, then the message, then the size of this message, and then 0. And after it we can return 1, indicating that this actual function worked. Okay? So this will be our boot run function, and we successfully added it to our program, and we're going to see how it works after we finish the entire malware and the entire server. We're going to test all of these functions and fix them if we have any error. So even though this was one of the little harder videos, I hope you actually understood most part of it at least. If you didn't understand something, feel free to post in the Q&A section and I will respond as soon as possible. Okay, so thank you for watching this tutorial, and we're going to continue coding in the next video. Bye! Hello everyone and welcome back. And we're actually getting close to finishing up our program. All we're left to do is add one main function to it, which is adding our keylogger. So how we are going to do this? Well, I already have the keylogger coded in a separate program. We're going to go through the code, explain some of the basics, because I don't want to just add it to our backdoor and not explain any of the code. We will go briefly through the code, explain how everything functions, and then we will see how we can implement our keylogger to our backdoor while still running the actual backdoor. So the goal here is to actually run the keylogger in the background and still be able to execute other commands simultaneously. So let's see how we can do that. Before we do any of that, let's check out the code of our keylogger. And for you, you will have the code of the keylogger in the resources of this lecture. But it would be better if you just simply download it and follow along. Okay, so I will open up my terminal. And right here, my keylogger is actually stored in this brute force directory, so I will navigate there. First I will go to my desktop, then I will go to my brute force directory, and I will enlarge this screen and also zoom in so we can see everything better. Okay, so if we type ls, here we can see the keylogger2.h. This is our file. The first thing that I'm going to do is I'm going to rename it to keylogger.h. Because there is no point in having these two. I only have it because I already coded one keylogger before, so I call this one number 2. but it doesn't matter at the moment, so let's just nano the keylogger.h. And here you will see this is quite a big code. It is not a small function that we will add to our program. And you will see right here, some of these statements are already being explained. Such as, for example, this infinite loop right here, taking the rest to our program. As we can see, we used sleep function, which we are already familiar with as we used it in our backdoor. So most of the stuff right here is already explained. But let's go through it in a little bit more detail. So here we define our function. As you will see, this is not a program on its own. This is a program meant to be added to a different program. Here we have a log function which will be used in our backdoor, and here we made it to be a double word win API, which is really not necessary, but we're simply just going to leave it on that. It doesn't really matter, but you should keep in mind that this is really not necessary, and you can simply just make it an integer function and also import it into your backdoor. So here, the next thing we do is we define multiple variables. Now, the most important and key variables to this are these integer variables right here, as well as this show key variable right here. Now, I will explain them as we get to the actual part where they are used. Right now, let's go down, and here we have some char variables, which we will use in order to actually print out certain characters inside our keylogger. Then we define a file descriptor, and we need to actually create a file because our keylogger will be based on inputting the keystrokes inside of a file. That's why we have these two lines right here. We create the file descriptor, and we also create a character variable, which is keylog file, which will be called windows.txt. Now, if you want, you can change this to anything you basically desire. I just called it windows.txt because it doesn't really look suspicious once seen in a directory. Okay, so this will be the name of the file where we're going to input our keystrokes, and this will be the file descriptor to that file. Now, let's go to the main part of the program, which is this while loop. Now, this while loop will run forever. It will iterate over certain keyboard inputs, and it will define each keyboard input as a certain character. So that is the main part of the actual program. So how will it actually do that? Well, first of all, we take the rest for 10 milliseconds right here, and this will be executed at the beginning of the while true loop every time it finishes one iteration. Then we perform a get key state function to all of these integer variables. Now let's first define what this get key state function is, as it is the most important and critical function to this program. So here is actually where the program gets a little bit hard. Or I will just say it will get syntax heavy. It's not really hard to understand as it is working on a basic principle. So all we are doing here is comparing different ASCII characters using this function right here. This getKeyState is the main function to this program, and by main I mean it is essential for this keylogger to work. It will retrieve the status of the specified virtual key. Now, what a virtual key is first of all, it is a type of integer, and if it is a letter or a digit, it must be set to the ASCII value of that character. For other keys, it must be a virtual key code. Now, I assume most of you know what ASCII means. Basically, ASCII is a different representation of different characters and digits in hexadecimal. So, for example, I believe, I'm not really sure about this, but I believe like 0x42 is capital A, or capital B, I'm not really sure, but it is represented like this. And then what we are doing is we're converting that back to its actual letter or to its character representation. Okay? So let's try to explain it actually a little bit easier so everyone can understand with just one sentence. So what we're going to do in this entire program is taking the user input and running a getKeyState function onto every character in order to see what character it is. So if we get 0x42, for example, we will know that that is a capital A, and that's how we're going to define it inside of our windows.txt file, which we defined at the beginning of the program. Okay, so here we can see we are opening a for loop, and we're using the virtual key as an actual statement inside of the brackets, and this is pressed integer will retrieve the actual result from the getKeyState. This is a variable that is going to store the return value of the getKeyState function. So if the value is equal to 1, that means that the key is down, and if the value is equal to 0, that means that the key is up. That's why we are comparing right here whether isPressed is equal to 1, because if it is equal to 1, that means the key is down. And this showKey variable right here is going to store the character representation of the virtual key. So once we figure out which virtual key it is, we're going to represent it in a character statement, and we're going to store that inside of this showKey variable. So you will see throughout the rest of the program bunch of these if statements, and here we're simply just checking for 2 or more conditions, whether both of them are being met. And first condition being isPressed to be equal to 1, and second one being lastKeyState equals to 0. And we defined lastKeyState at the beginning right here inside of a for loop. Okay, so if I go all the way down and pass all of these actual if statements, we get to another part right here which is really important, and that part is actually writing the character inside of a file. So once we pass all of those else if statements and decide which virtual key we got, we then transform that into a character representation, store it in a showKey, and then in the last if statement, first of all, we check if the showKey variable has any character inside of it. If it does, we will open the file that we created at the beginning of the program for appending, and this A stands for appending, which means we will consistently add different characters to our file. And to do that, we use this putC function. This putC function takes 2 arguments. The first one is the actual character that we want to put inside of a file, and the second parameter is the file descriptor, or the file where we want to put it. So we're simply just putting our character inside of the windows.txt file. And after it, we close the file descriptor. Okay? So this entire action will be performed for every single character the target inputs in their keyboard. Alright, so now that we know how this program works, in the next video we're going to see how we can implement it into our backdoor. Now that we went through this file, let's see how to implement it inside of our backdoor. So first thing I'm going to do, I'm going to save this file and move it to my desktop. So move keylogger.h to the root and then desktop. Once I have it on my desktop, I will switch my directories. And by the way, you might have noticed that this actual file, which is our keylogger, doesn't have the .c extension. Now, the reason why it doesn't have .c extension is because we are actually going to import it or include it inside of our backdoor as a certain library. Now, we already know how we included our libraries inside of our backdoor, so if I nano my backdoor, you will see at the beginning we have these include statements right here. And you might have noticed also that all of these include statements have .h extension to them. This H stands for header, which basically means we are using a certain functions inside of our backdoor program from these headers right here. So we're going to perform exactly the same thing, just this time we're going to include our own header. And our own header is called keylogger.h. So we include it like this. You type the hashtag, then the include statement, then you open the double quotes, and then keylogger.h, and then you close the double quotes. Only then we can access the log function, which is coded inside of our keylogger. Okay, so right now let's go all the way down and see how we can access that function. First, we're going to go all the way down just above the else statement, and we're going to create another else if statement right here. So else if, and here we're simply just going to compare the commands as usual with our keylogger. So string compare, open the brackets, in between the double quotes, we need to specify the command we want to type once we want to execute the actual keylogger. So in this case, we can use a simple command, which is keylog_start. So anytime the user of the server inputs this command, it will get sent to the backdoor. The backdoor will compare this keylog.start with the buffer. Then it will notice that it is actually equal, and then it will start the keylogger inside of the background. So we're comparing this with our buffer, and we're comparing 12 characters, okay? We also need to make sure that this is equal to 0. If it is, then we are ready to start our keylogger. So how can we do that? Well, keep in mind that we do want to make it run in the background so we can still continue executing different commands in the meantime, but the only way we can actually do that is if we create a thread. So we create a thread that is going to run our keylogger separately. Now, how do we create threads inside of a C program? Well, we first of all need to define a handle. That handle is going to be a handle to our thread, so we're simply just going to call it thread. And now we will make this equal to the return value of a function which is createThread. And this createThread function will take several parameters. First one we will define as null, second one will be 0. Now we are not specifying anything outside of the actual function that we want to perform the thread on, so everything else will be just null or 0. And the third actual argument or parameter is the name of the function that is going to perform the keylogging. So before we do that, we need to make sure that we specify the name of the function correctly. So let's go and check out what is the name of the function. Let's save this, nano our keylogger, and we can see the name of the function is log with 2 G's. Okay? So this is the name of the function that we need to specify inside of our createThread function. Let's close this, go back to our backdoor, scroll down to the else if statement, and here, as a third parameter, we specify simply just log. Okay? So the rest of the parameters are simply just null, 0, and null. So we are not defining anything else. Once we actually finish this creation of thread, we can simply just use goto jump in order to jump back to the beginning of our while true loop and wait for a second command. Okay, so let's save this, and believe it or not, this is everything that we need to do, just this one single line in order to start our keylogger. And in the next video, what we are going to do is we are going to check all of the added functions to our program and update our server, since our server from now on only has the ability to send the commands which the target will execute. We haven't updated it with these specific commands. So we're going to do that in the next video, and then after it, we're going to perform a final test of our backdoor. So hope you enjoyed this small tutorial, and I will see you in the next lecture. Bye! Welcome back everybody. Now that our backdoor is finished, we're ready to update our server correspondingly and then test our program. So let's nano our server and let's see what we have for now. We have the main part of the function coded, and there is nothing that we will change right here. All of this will remain the same. Only thing we need to update is this while true function right here. So we, for now on, only have two statements, which is the Q statement when we want to quit the program, and the else statement where we want to receive the response from the command that the target executes. But you will notice if we just leave it like this, and for example try to execute the keylog start command, we will send the keylog start command right here, and then it will compare the buffer with Q, and keylog start is not equal to Q, therefore it will go to this else statement. And we will get stuck on this receive function right here on waiting for a response from our target. But you already know by now that the keylog_start function that we perform inside of our backdoor does not retrieve any output back to us. So therefore, this program will crash once it gets to this statement. Or it will not crash, but it will get stuck and it will never receive the reply because our keylog_start function never sends the reply to our server. So we need to see how we can fix that. Well, we're going to fix that with the usage of this jump statement right here. So we're going to fix one by one command with the help of the jump statement. Let's go with the cd command first. Else if the string compare of the cd command, make sure that you add space right here, since we already explained why we need it. We compare this with the buffer and the first three characters. That has to be equal to 0. Then we will open these brackets. And all we are left to do right now is type go to jump. Okay, so this is everything that we need to do. Since when we change the directory inside of our backdoor, there is no output that is being sent back to our server. Therefore, all we need to do is go back to the jump, which will prompt us for the next command. And then we can do that again and change the directory again, and it will prompt us once again for the next command. So the next command that we also need to add is the keylog start command. We're going to string compare keylog underscore start with the buffer with the 12 character size, and that has to be equal to 0. And then we're going to perform the same thing, which is going to be go to jump. Now for the actual persist command, we don't need to do this, because in the boot run function that we coded inside of our backdoor, which creates the registry key and all of that, it actually sends back the response back to our server. So therefore, with that command, we can simply just proceed to receive the response and print it to our screen. So that would be about it for this server. And in the next video, let's see how we can compile our both programs and test them to see if they work. If they do work correctly and we manage to fix all of the issues that we might have, then we're going to proceed to actually making it more difficult to detect, such as for example disguising it into a PDF file or into an image or any type of file that we want. And after that, we will see how we can actually make it even less detectable by performing some manual obfuscation. Okay, so thank you for watching and see you in the next lecture. Bye. Okay, so finally we are ready to compile our final product and see how it performs. Now we already know the commands on how to compile them, on how to compile our server and our backdoor, so I will not go into the details of what we are doing right now. We are simply just performing the same commands that we typed in order to compile in the first performance or first test of our program. So first of all, we are going to start with our server. So we know that for this server, it is a simple command, which is gcc server.c and then -o for the output name, and we're simply just going to call it server. Press here enter, and we can see we don't run into any error inside of our program. If you do run into some error, you can simply just read through the error and easily find out where the error is inside of your code. If you can't figure out where the error is, make sure that you post it in the Q&A section with the screenshot of your code, and I will help you to find it. So now that we compiled our server, let's go and compile our backdoor. We start off with the i686, and the reason, once again, is because we are compiling our backdoor as a 32-bit program. So let's perform the entire command right here, and you will notice if you simply just type i686 and then W and press here tab, it will automatically autocomplete this command, and all you're left to do after the last dash is add gcc. Once you do that, we can go and type -o, which will be the output name for our backdoor. We will call it final product.exe, and then we need to specify right after it the name of the C file that we are compiling, in our case backdoor.c, and we need to specify those two libraries that we need in order to be able to compile this program for Windows. And those two libraries are lw inet and lw soc32. Press here enter, and we can see we do run into an error. So let's see what the error is. It says it is expecting dot and comma before the brackets inside of the boot run function. So let's fix that. We will nano our backdoor, go to our boot run function, which is right here at the beginning, and find where is the missing dot and comma. Here we have it, here we have it, and here is where we are missing it. So let's add it right here. Save this program, Ctrl O, enter, Ctrl X to exit, and then we compile once again. Using the same command, press your enter, and it seems to work correctly. Now, once you get something like this, which is an exe file that has this type of icon, I'll tell you right away, this will not work because sometimes the actual compilation fails and it doesn't compile it entirely. Therefore, if you get this icon right here, in case you're using Kali Linux of course, make sure that you recompile it once again. So I will just delete the final product.exe and run the command once again. And right now I have the final product which has the correct exe icon. And this one will work. Or I hope it will work, at least. So let's transfer that final product inside our USB drive and test it on our Windows 10 machine. I will import my USB drive. Then what I'm going to do is I'm going to move the final product to the media, root, and then the name of my USB drive. Then I'm going to unplug my USB drive, enlarge the screen. I will run my server, so it will wait for the incoming connections. Then I will go to my USB drive, find the final product. Here it is. Paste it onto the desktop and run it. So we can see nothing is happening. Let's go to our Kali Linux machine. And it doesn't seem that we managed to get the connection back. So let's see what's wrong. We're going to Ctrl-C this. And the first thing that I actually have on my mind is to check out the IP address of my Kali Linux machine. So the IP address is 192.168.1.6. And this is something that we should have checked even before the compilation. So what I'm thinking is that the actual compilation compiled it with a different IP address. So let's go all the way down. Here it is. We need to change this to .1.6. Save it. Now let's go to the server as well, because the server has the same IP address, which is .1.8, and we need to switch it to .1.6. Also make sure that you double check the ports as well, whether they are the same in both programs, and once you do that, we can recompile our programs. So I will remove the server, which is the compiled version of the server, and I will use the same two commands that we used before in order to compile these two programs. Okay, so here we have them once again, and let's just copy this. While this is copying, I'm going to delete this file. It is still running, so we need to go to the task manager to actually kill it, because it is actually trying to connect to the 192.168.1.8, and we changed the IP address to our Kali Linux machine, so we're going to find the final product.exe. Here it is, 32-bit version and task. Now we can delete it. Once we do that, we can move our final product to the media, root, and then USB drive. Unplug it once again, so we know the process. Run the server. And let's check out whether it will work right now. Okay, so double click it. It seems as nothing is happening, but if we go to Kali Linux, we can see we got the connection back from the Windows 10 machine with the IP address of 192.168.1.4. So let's try to execute first of all normal commands. If we type who am I, we get the output ipconfig. We also get the output. Let's try with some netstat commands. We get the output for that as well. If I just type dir, we get the output of the current working directory, and we can see all of the files inside of it. Let's go one directory back, type dir once again, and right now we're in one directory back. So let's go back to our desktop, and let's try to start our keylogger. So before I do that, I will simply just open the notepad file right here, where we are going to type some random things and see whether our keylogger will manage to capture it. So if I type keylog_start, we will get right away back the prompt where we can send in second command, and if we send the second command, we get the output, so we can still execute the commands, but this keylog_start started the keylogger on the target machine. So if I go back and start typing something, hello world, you will notice right away that the windows.txt file opens up right here on my desktop. I didn't create it, it automatically was created right here, and right now it is writing all of these keystrokes that I'm putting in inside of my keyboard. So let's go with my password is password 123 with the shift usage, so exclamation mark, @ and then hashtag, and then 456. Then we're going to close this, not save any of this, and let's see if we go back to our Cal Linux machine whether we managed to capture it. If I type dir once again, you can see I'm still on my desktop directory, and you can also see that there is a new file which is windows.txt. In order to see what are the contents of this file, and in order to type them out, we will use a simple command which is type windows.txt. Press here enter, and you can see we get the output which is hello world, my password is password, and then exclamation mark, @ hashtag 456. Now this will also work on the online pages, so for example, if the user wants to go to, let's say, paypal.com, so they open up their browser right here, I'm currently using the Brave browser, they navigate to paypal.com, they try to log in, so they go on the login button, and right here they specify something randomly, and right here they specified test1234. We press here login. Of course this account does not exist, but if you go back to our Cal Linux machine and type the same command which is type windows.txt, you will see it also managed to capture the actual password and the username. As we can see, the username was this, and the password was test1234. So our keylogger works correctly. Now that we know that keylogger works, let's see whether we can create the registry key when using the persist command. So what I'm going to do before actually running the persist command is I'm going to go to my search bar on Windows right here, type the run, and then press enter. It will open up this small window. I want to type in the regedit, press here on OK. It will ask me for administrator privileges. I will click on yes. And right now I want to navigate to the path where we will perform the creation of our registry key for our program. It is in the HKey current user. Then you go to the software. Then you go to the Microsoft, go all the way down. Then you go to the Windows, current version, and then you find run. So right here, once we execute the persist command, we should see a new registry value which will be called hacked. So let's try it. If I just go right here on persist, press here enter, and then go to my registry, press F5 to refresh, we can see a new registry value has been added. It is called hacked, and it has a path to our final product.exe. So right now, even if the target shut down their PC, next time they start it up, our backdoor will try to connect back to our Cal Linux machine. But you will notice one thing, which is that once we execute the persist command, we're not getting the prompt back, and we cannot execute any more commands. So we're going to see how we can fix that. It is a simple fix, and we're also going to see how we can add a message to the target if we want. For example, let's say we want to prompt to the target a message, "You have been hacked." It is a small little addition to the program, and I will show you how you can do that if you like. If you don't want to do that, if you want your target to not have any idea that they have been hacked, you can just not prompt them with anything and make them not even aware that they have been hacked. So thank you for watching this demonstration. Everything works correctly. We're going to see how we can fix this and how we can execute the commands right after the persistence command in the next tutorial. See you there. Bye. Welcome back everybody. And in this video, we're going to see two different things. First one is how we can actually fix the error from the previous lesson where we executed the persist command, but it unfortunately just was hanging there and didn't want to let us input the next command. And another thing that we are going to see is how we can message the target that their device has been hacked. So let's start with the first thing. I did fix the error and I'm going to show you how I did that. If I go back to the server, I will show you exactly what I added, and let me just zoom this in so you can see it a little bit better. If I go back all the way down, I added this part to my server code. And the reason why I had to add a separate receive response for the persist command is because of this message wait all. If you leave it with the message wait all, it will simply not work and it will still hang there forever and not let you execute the next command. So I added another else if statement, compare the persist with buffer, 7 characters, if it is equal to 0. I copied this command, but instead of message wait all flag, I specified 0, so no flags given. And then I print the response. So that is in my server code. Once you add it, you can save it. And in my backdoor code, I don't think I really added anything. The function remained the same, so everything is the same as it was before. And if I go all the way down, everything should be also the same. So we only execute the boot run function. So this is the part of the else if statement inside of the backdoor program. And the boot run function hasn't been changed at all. Okay, so before we compile the program, let's add a small message box to notify the target that they have been hacked. So where and how are we going to code it? Well, we're going to go into our main function and scroll all the way down right below the actual connection. So once we execute this loop, we want to code the message box between this connect function and the shell function. So before we actually go inside the shell function, we want to prompt the user that their device has been hacked. And this is an optional thing. If you don't want to do this, you don't have to. Perhaps it might be even better to not notify the users that they have actually been hacked. But you can use this method in your penetration tests in order to prove to the target that you successfully managed to hack them. So how we can do that? We can simply just type message box. The first argument will be null. The second argument will be the text type, and inside of that argument is the actual message that we deliver to the target. In our case, we will specify your device has been hacked. 3 exclamation marks. The second argument, or pardon me, the third argument will be another text type, and this will be the actual header name of the window that will get prompted to the target. And you will see what I'm talking about. So if I just type here, for example, Windows installer and leave it like that, all I am left to do is create the actual icon and the OK button that the target will be able to click. In order to do that, I will type mb_OK, which this represents the OK button in the standard Windows window. And we also want to specify the standard icon error. So enter pipe, which is this vertical line, and then mb_icon error. And at the end, dot and comma, Control O to save this, Control X to exit, and let us compile both programs once again. So if I go right here, search for the previous commands, first of all compile the server, then compile the program as a final product.exe, press here enter, and right now I'm going to transfer it in order to test it. So I will copy the final product inside media, root, and then my USB drive. Unplug the USB drive. Right here, we're going to paste it onto our desktop. Here it is. Now we can run it, and before we run it, I actually have my task manager opened and my registry editor open. So we can see right here, if I refresh, there is no registry key for our program, and also it is not running inside of the task manager. If I double click on it, it is executed. Let us find it in our task manager. So here it is, final product 32-bit. The registry key has not been created yet. So let's start our server. And you will hear this error, and if I go back, you will get this window prompted, Windows installer, your device has been hacked. And we can click on X or we can click on OK. So this is just a small fun thing to do. There is no need to do that if you don't want to. And if I go back to my Kali Linux machine and execute the commands, everything will work normally. ipconfig will give me the IP address, dir command will give me the directory, and if I want to, I can run persist, press here enter. We now get the response which says created persistence at this path. If I go to my registry, refresh, we can see the persistence is created and we can see the registry key and value for our backdoor. And I can also execute once again other commands if I want to. Switch the directories as well. So everything works perfectly. Now that our backdoor has been finished, in the next video I will show you how you can make it even less detectable by antiviruses. If you notice right now, the Windows Defender newest version does not detect it. I don't have an antivirus, so I can't really show you that right here, but I will show you in the next video 2 different techniques that you can use to bypass most of the antiviruses. So hope I see you there and take care. Bye. Bye. Welcome back everybody. And let's see how we can disguise our malware to look like any other file type. So, we already saw how we can disguise an exe file, including our malware, to be an image at the beginning of our course. Here are the 3 files that we used, which is the icon to an image and the image itself, and of course our malware. We used this website right here, which is the iconconvert.com, to convert our JPEG image to an ICO file so we can have the same icon as our image. But right now, let's see how we can create other file types. So, here we have our exe file, and let's say we want to create a PDF file out of it. So right here, if I go to my files and to icons, I will have a presentation report PDF file which opens some penetration test presentation report. Let me open it in Brave. And here is how it looks like. It has been downloaded from the internet and we're going to use it as our malware. So we're going to create our malware to open this PDF file, to have a PDF file icon, and to also start our backdoor in the background. Let's see how we can do that. There is a website called Icon Finder, which has some icons for free that we can download. So if I click on this website, it will tell me search for icons. In our case, since we want our malware to look like a PDF file, we're going to type right here PDF. We want to go right here onto free. And here are all the free PDF icons that we can download and use. Right now we can use any of these that we want, but let's for example go with this one. So you will notice that this actual PDF comes for download either as a CFG or as PNG. So we're going to click download this PNG. It will ask us where we want to save it. I will say it onto my desktop. And we can see it actually saved a PNG image. So we can't use this file for our icon. We need to convert it using our converter. So we will choose a file right here. Find our PDF icon, here it is. Upload it. Go all the way down, select 64x64 and convert to ICO. We'll go and download your icons and we will save it right onto our desktop. So here is our icon, it has successfully been downloaded and right now we can create our file. So here is one thing we need, the second thing we need, and the third thing that we need. So let me check out right here, which file type is this? This is the ICO, so this is what we're going to use. And let's select these 2 files and click add to archive. So once again, for this, you will need WinRAR installed. So let's call it report.pdf.exe and you will see it will automatically check right here, create SFX archive, and we will go to the advanced SFX options, go to the setup, type right here the name of the file that we want to actually execute first. And before I do this, I will move this window, copy the name of this file, so Ctrl C to copy, Now I will go to the SFX options, setup, paste the name, add.pdf, and then the next thing that we want to execute is final product.txt. Okay, so under the modes we want to click on unpack to temporary folder, and we also want to check hide all. Under the advanced there is nothing really that we need to do. So let's go to the module, nothing here, nothing in license, text and icon. So under the load SFX icon from the file, we want to click on browse, select our icon and go to the update, click on extract and update files, and also click on overwrite all files. After all of that is set, we can click here on OK, and we can also click here on OK. In just a few seconds we will have this report PDF file, which will have the icon that we downloaded and which will also be called report.pdf. If I start my task manager, I will check whether our program has been started in the background, so we don't have to use Kali Linux. So right now there is no final product being ran in the background. But if I double click this file, it should open up the PDF file that we embedded malware in, and here we can see it is opening it right here. The PDF file has successfully been opened, so we can close this right now. Let's see if our malware is also running. And here it is, final product 32-bit is running in the background. Once again, nothing is being shown on the target desktop. So let us close this. And another thing that you can do, which can be really actually useful if you have the access to the target machine, you can create a Google Chrome out of this malware. So you will need a Chrome or Firefox shortcut, and I have one right here. Let me just find where I saved it. Okay, so it is probably in the icons right here. And here is my Chrome shortcut. I will paste it onto my desktop. And all I need to do is I need to go to my icon finder website, type here Chrome, click on free, and we can choose any Chrome icon that we want. You can go with the black one, with the blue one, or you can go with the regular one. So I will just go with the regular one. I'm not sure if it is this one or this one, but it doesn't really matter. Just click on any of those, click on download PNG, save it onto your desktop, go to the icon converter, scroll all the way up, choose a file. Here is our icon or the PNG image of the icon that we want to create. Let's select it, upload it, go to 64x64, it is already being set, and convert icon. Let's click on download your icons, save it onto the desktop as well, and everything is set to go. So all we're left to do right now, we have our icon right here. We need to select the Chrome shortcut and the final product shortcut. Go to the add to archive, do the same thing as before, let's call it Chrome with capital C.exe. And we will go to the advanced, and you will notice it will automatically check create SFX archive, even though we don't have any other extension other than .exe. So let's go to the advanced, SFX options, and set everything as previously. First we want to start Chrome.exe, then we want to start final product.exe. Everything else we will set as previously. Text and icon, select your Chrome icon, update, extract, overwrite, click here on OK, once again on OK, and here we have our Chrome malware. And now what you can do is you can take this Chrome malware and put it in the taskbar. Now you can do this if you have the access to the target machine, and of course you would unpin the real Google Chrome right here, and then once the target goes back to their machine, they want to go to the internet, they click on the Google Chrome, it opens up the Google Chrome, everything looks normally, Chrome is being opened. If we go to our task manager, we can notice right here in the background our malware is being ran. So here it is, final product 32-bit is being ran on this machine. So once again we successfully started our malware. Okay, so that would be about it. Now the same principle of converting a file into a different file goes for any other file type. For example, if you want to create an MP3 file to embed our malware in, you would do the same process that we did with JPEG, PDF and the Google Chrome. So everything is the same for any file type, and that would be about it for this tutorial and also for this course. I hope you really enjoyed it. I hope you learned something new with C programming. Thank you once again for watching, and I will see you in some other course. Bye!